सरस्वती नमस्तुभ्यं सर्वविघ्न ज्ञानदायिनी सर्वदा सर्वकार्येषु सर्वदा वरदा. O Goddess Saraswati, a giver of knowledge, please bestow on us your blessings on whatever we are going to start today. And we are going to start today the National Conference on recent trends in mobile and cloud computing. Honorable Dais, my dear colleagues and my dear students, it's an honor for me to come over here all the way from Amravati to Washim. And as it is a national conference, and as has been told that there are about 45 participants, somehow I could see only more students, and I don't know when the participants will arrive. Maybe by IST, Indian Standard Time, they should arrive. Right? Hopefully it's a 2-day conference, so at least they should arrive by tomorrow to get at least the certificate. Right? As you know, I have taken over as Vice Chancellor for about more than 4 years now. Earlier I was at VNIT Nagpur, and then from last 4.5 years, probably I think I have forgotten my engineering and it's a total administration. Two of us, my colleagues, they know well what I do there 24/7. It's a total administrative job, and when it comes to a technical conference, the inauguration of technical conference, and even otherwise also I would like to tell you that wherever I go, yesterday I had been to the importance of English in the era of globalization. Day before that it was the inauguration of RKA week, and tomorrow it will be gender sensitization. So every day there is some or other subject, and as a Vice Chancellor you do on speaking on the different subjects. It's something like jack of all and master of none. That's what my position is now. But then, if we talk about this college, as they have said that we should go for a job fair, jobfair.cc and all that, we can definitely do that. But at the same time, the other side of the story, I would like to tell them that you have to send the values for valuing papers also. Is it not? My dear students are there and they know what or how much time it has taken to declare the results this year, because I think probably a record break, no? Sort of thing, which the Amravati has made. I don't hope that it should repeat again. And so we need your help also, not only in the job organizing some workshops, but also equally in the university work. Hope that it will be done from the winter exam now onwards. So that is all about the college and the other things. Now let us come back to the subject. The subject is about the recent trends in mobile and cloud computing. So I will go word by word. I think recent trends there is nothing. We'll start with the word mobile. What for we use the mobile? The basic thing for which we are supposed to use is it for communication. Am I right?
Yes.
Yes. Now if it is for communication, do you know the origin of the word communication? There might be some electronics communication engineers here sitting, right? The word communication has the origin in a Latin word communis. Communis means to share idea, to share information. Here the information means whatever you are sharing even orally, because as I said it's RTA week, right to information week. There the definition of information is different. There whatever is stored in black and white, whatever is stored in your floppy or a hard disk, right? Some samples and all that, that's what is the definition there. Here as I am saying, the definition is different. And even the word commerce has the origin from the word communis. where it is to share the trade and the business. So that's what communication is. And my dear students, you might be knowing the first telephone was invented by Graham Bell in 1876. And then you might be knowing why we say hello. Do you know it? Yes. Because the Graham Bell's girlfriend name was Hello. Right? And so we say hello. It started from that date when the Graham Bell called first his girlfriend and he said hello, and from that day onwards we say or we start the conversation with hello. If you go to Japan, they say mosho mosho. Of course, in the different countries, the language wise it is different. Okay, that is all about the communication when we talk in general. When it comes to electronics, the communication means a transmitter, a media, or a channel, and a receiver. Is it right? That's what the communication here, the word changes so fast. There it is, as I am saying, just exchanging information. But it is not now the exchanging information, just like here we are sitting together, but then you are at one end and I am at another end. And for the information of my young friends, I would like to tell you how difficult it was 25 years ago. It's not a very old story I am telling. Just when we were young like you, to get a landline connection, there were no private operators in those days. It was only BSNL. There was nothing like a cell phone. And then to get a BSNL connection, it used to take 5 to 10 years at Nagpur. So if somebody is having a landline, it used to be a luxury. When I applied for a landline, I could get after 7 or 8 years. Imagine, just I am telling you. And even prior to that, the things were still difficult. When you wanted to make a STD call from Washim to Nagpur or to Amravati, you know how it was? You had to go to a telephone exchange, and then the telephone operator used to connect to Nagpur, and then to a particular telephone. It used to take maybe half an hour to 5 to 6 hours. So one fellow used to be stationed at the telephone exchange only. Why I am telling you, today you know what you do. Today you are having a gadget in your pocket. You just press the numbers and you can talk anywhere across the world. That is technology. That is engineering. That is important. Is it not? And the things are changing so fast. What is today you are using? When we were learning the engineering, we used to learn the diode, the triode, the tetrode and the pentode. And if you see the size of your radio, probably I don't know whether anybody has seen it because they have all been obsolete now. It used to be such huge. Then the things changed, the transistor came in, right? Then the ICs came in, the integrated circuit chips. Then it was LSI, it was VLSI and VBLSI. Very, very large scale integration. Why we did this? You know, who was the owner of the Intel, who started Intel? It was Murray. And Murray designed 4 laws for his company which have become universal then. He was there from 1964 to 2004 and he wanted to bring up the Intel in the global market, which he did of course and which he was successful. But you know what was his 4 laws? Murray's law? No? None of you? So, we are a technocrat, we are talking about cloud, we are talking about mobile, at least we should know Murray's law. The Murray's law said, you know what is the generation gap in electronics? Because if we talk in general, we say the generation gap is 20 years. Is it not? The first generation, the second generation, the third, so on and so forth. Why I am saying so? Again, because when we were kids, 50 years ago, I can tell you the story. In our house, what used to happen? Whatever father says is correct. We never used to argue. Then the generation came, now 20, 30 years later, wherein now you operate with the mobiles, the emails, first they come up. And when I used to tell, because whatever mobile I am using, hardly I use 20% of its functions, I think. And 80% of them are just like that. But it is like a status symbol. If I say that I would like to purchase a mobile of less than 10,000, my daughter and my nephew will say, "Arey, sir, 10,000 का कोई नहीं रखता है। आपका तो status कौन सा है 20,000 के ऊपर वाला मोबाइल की। So I purchase 20 plus. I won't use it. But then if I tell some function that I know this and that, then my daughter says, अरे ये तो मम्मी को भी पता है, ये कौन सा फंक्शन बता रहा है, बहुत नया बता रहा है, ये आपको नया लग रहा है तो बहुत पुराना हो गया। There are so many functions which have come up later. It doesn't end there. I had been to US 2-3 years ago. I was staying with one of my students, and both of them were IT engineers. They were having a kid 4-year-old, and then she was asking me something about the iPad and the mobile. I said, I am totally illiterate. Don't ask me anything. I will not be able to answer. But then I requested her, you can ask your parents. Both of them, they are IT and serving in US. They can tell you better. You know what that little girl told to me? My parents, they don't know anything. So from the day 50 years ago, when we assume the parents know everything, now the generation has come where they say parents don't know. And that's a generation gap. Probably it may be true to some extent, and I'm not blaming anybody. If it is a positive change, if the technology is advancing and probably the old generation is not knowing, fine, there is nothing. But then, the Moore's law came in between, because if you see how you want a mobile, can you think of a mobile which is half inch or 1 inch nowadays? No, you want a sleek design. If you take like that, earlier I used to have some 5-7 years back, and then my kids used to say, "Papa, ये क्या compass box लेके जा रहे हैं?" ऐसा थोड़ी जमाना है आजकल। एकदम sleek वाला, छोटा, smallest size mobile that you should carry, and with more and more functions. And the Moore definitely was knowing in those days what the future of electronics is. He said, as I said, there is the gap of generation was 20 years. In electronics, it is 18 months to 24 months. Let us take it as 2 years. So in 2 years, he says, the number of transistors which you are using on a chip, they have to be doubled. Right? Number of transistors to be doubled. The chip size should be reduced to half. Getting it? The number of transistors to be doubled, but then the chip size to be reduced to half. The operating frequency should be doubled, right? The third law, but the power consumption should be 1 by root 2. And you will find all the things are contradictory. Those, I think, the students and the staff who are from the electronics and computer, they must be understanding what I am saying. When you say that the transistors you are doubling, and then the chip size has to double, but then you say that chip size should be half. The frequency to be doubled, and you say the voltage or the power should be 1 by root 2 times. So out of these 4 conditions, in a 2 year, if you can achieve one, at least one you have to achieve, if you want to remain in Intel, otherwise you will be kicked out. So you have to achieve one, it will be a good design. If you achieve 2, it is the best design, and it's difficult to achieve 3 or 4. All the 4 you could never achieve. I think my electronic friends will agree with me. It's difficult to achieve. So then, the Moore was knowing those days that the design which you want will be something like this. And then, earlier as I said, if I want to listen to radio, I have to go on for radio. If it is a tape, I have a gadget, another gadget is a tape recorder. If it is a camera, I have another camera. If I want to use internet, I would like to have a computer or a laptop. But now, everything is there at your fingertips. You carry one gadget and you have everything, almost all the functions included in it, you name it and you get it. Is it not? Earlier, as I am saying, you have n number of gadgets. So the world has changed so fast, it has transformed. It is again because of the technology, the change in technology. And that's what is a mobile. But then, how comes the cloud? You know, when you are tuning to a particular frequency, when I was saying 96.6 megahertz as an Nagpur station, so a particular frequency used to be allotted to it. When you want to communicate, you know, you have to have a particular frequency or a bandwidth. That's the only channel through which you can do. And it's a modem through which you normally do it, modulation, demodulation. Okay. Now the frequency was allotted and that was fixed. Now, what will happen? There are how many users you know? Probably mobile users. Whatever is the population of India, 80% of it is the sale of mobile in India. 80%, remember. We can say that it is the 80% population, but I will not stick to that because you know that most of us we use 2, 3, 4 and 5. So population wise it is difficult to tell how much it is. But as far as the figures are concerned, it is something like 80%. Now with this now, and everybody wants to have internet, a Facebook, a WhatsApp. Now the question really comes. Earlier, you know, when I want to use the internet, I used to sit in my room, whether it is the office, whether it is my home, and I used to get the connectivity. Later on, I wanted 10 of computers, the whole engineering college, the whole department, I used to have LAN, or local access network. The things have changed further. Now when I am coming from Amravati to Washim, I wanted to access the internet. Right? Or wherever you are, now you want to access the net. Earlier, as I was saying, at least the consumer or the fellow who was using the internet, he was at a single place, so it was comparatively easy to feed it. Now, with his changing location, and he wants access all the time 24/7, how we should go about? The frequency bands are limited. Is it not? The audio frequency bands they are in megahertz, the video they are in gigahertz. And now you want to use the same band. As I was saying earlier, you are giving a particular frequency to a particular station. Now if we do that, do you think that you can satisfy 128 billion people of India? Forget about the globe. And even you know, this is not somebody else who has invented Facebook. Who is it? Mark Zuckerberg. At what age is it invented? At a tender age of 20 in Harvard University. He was just like you. And what is the Facebook today? If we consider it population wise, worldwide, it is, I think, one of the largest globe, another globe. So many people use. Now, if this is the case, and you want to access the internet through and through, the only choice remains is that now you should have a data which is stored by somebody else. You should have the program, you should have the network, and what not stored somewhere else, and then you will be able to use it. And then where to store? So there are third-party operators available like IBM, Google, Verizon, and so on and so forth. What they do? There it is a cloud computing. where now I want to access anything, anytime, anywhere. And even as I said, when I am traveling, I want to access. It is not only at one place. What is the choice like? I want so many functions at my fingertips, so there has to be somebody, service provider, who should give me all these services. And so the cloud computing came in. In short, we call it as a cloud, wherein now the cloud has a network, a database, a data mine, the program, and whatnot. You name it and you will have it there. And now as a user, you can try it from anywhere, anytime, 24/7. Even when doing so, as I said earlier, it used to be a fixed frequency. Know what you are doing. Now, let us say when my mobile was on, I was using a particular frequency, I switched it off, now the frequency was given to you. She switched it off, the frequency was given to a third fellow, so on and so forth. It is multitasking, multiplexing. Because as I said, the frequency bands are limited, you can't increase. And so, whenever you wanted to use it, the same thing as, let us say you can have a simple example, if you are having a scooter or car, and only one scooter in your home, what you do? You use it once. When you park it, your brother or sister will use. When nobody is using, your mother will use. What is it? It's the same thing used by n number of people. So same is the thing here. The same frequency being used by a number of people. And for that purpose, there is no choice than to have a cloud computing. Because then you have to allot these different frequencies to different users. And it's not that easy task. And why we did so? Because now in India, when they are working hours, in US, what is it? Now it's a night time. There are no users at all, or very less users. And when they are having a daytime, we are having a night time. Is it not? At night, you just park your vehicle, nobody uses it. So here, it's a concept of electrical grid, wherein from a grid you tap the supply anytime, and you get it. You just switch it on, and what happens? Your bulb glows, your fan runs, your AC runs. Why? Because the supply is available in the grid. There is somebody who is putting it, and then you are tapping it as per your demand. The same thing is about the cloud. Somebody has already put it in a grid, now you are just tapping it. And remember, my young friends, when we say so, the things are not at all difficult. I will give you another example. Have you heard of SCADA? Supervisory Control and Data Acquisition. Right? So what is it? When I go to MSAB, when I go to some other people to deliver it, the people say, sir, we don't know. Simple is okay, I will tell you in a very simple way. Now, what's a simple way of telling SCADA? Let us say you are driving your bike or a scooter. If somebody comes in between, what you do? You apply brakes. Why you won't press accelerator? You are going on a bike, somebody comes in between, what you do? You said that you apply brakes. My question is, why you are not press the accelerator? करते नहीं? ये तो पता है क्या होगा? Now, let us see the phenomena which is occurring behind. You are sensing that object through the input device. The input device is your eye or eyes. From eyes, it is going to your CPU, the brain. Is it not? Now the brain will process it along with the programs stored in the memory. There are lakhs and lakhs of programs which are stored in your memory. And what it tells you now? Stop. It tells you to apply the brake. If it is a foot brake, you apply foot brake. If it is a hand brake, you apply hand brake. And then you give your output signal and you apply the brake. So tell me how much time you have taken for it?
Fraction of a second.
Fraction of a second. Is it not? Yes. And how the things have gone up? It is not a solid state electronics, it is a liquid state electronics. And probably, as I said, when I was talking about a diode and triode and pentode, You are looking at me, अरे sir क्या बता रहे हैं? इतना बड़ा रेडियो रहता है. Now when you will grow up, your kids will look at you like this. ये कौन सा बता रहे? Solid state wireless है वगैरह. मम्मी पापा अभी तो liquid state electronics आ गए. Right? So in electronics, every day some 2,000 pages are getting added. It is changing so fast. So if you want to catch it, you have to run. Even if you walk, you will lag behind. The knowledge is changing so fast. And you have to acquire it. You don't have any choice. Because when we say that we are using a mobile, do you think that the mobile which you are using, the processor chip is manufactured in India? No, you are importing. And if somebody someday says that he will not export to India, what will happen to you? Just imagine, as an engineer, these are imported chips which we are using. And so our Honorable Prime Minister is saying now, you have to think of make in India, made in India, made for India, made by India. What you have to say? You have to think of now these IC chips to be fabricated over here. Why you are using the IC? Because when I was testing the electronic circuits, we used to have RLC and a transistor. And then we used to test the voltage or the current, and then whichever component has failed, we used to take out and replace. Now what happens? It's just an IC chip. Even if you tell somebody else to test it, it need not be necessarily engineered. What you will do, you will just throw out the IC and just replace it. It's so easy now. The things were extremely difficult in those days. Now as I am saying, as it is advancing, and as everybody wants to have access towards internet, as everybody wants to have a cell phone in his pocket, what is the choice left? There is no choice than to go for cloud computing. We will provide so much data. We will use so many frequencies. There is no choice. But then as an Indian, we have to also have, as I am saying, a word of caution that all the chips which we are using, they are imported, and that's not a very good sign for all of us. When we say we are technocrats, when we talk about a sustainable development, when we talk about the sustainable economic development, we have to also see, because what has happened due to this has changed the economy totally. Is it not? Now do you find anywhere a Godrej typewriter? Earlier in our days we used to have the Godrej typewriters. It has become obsolete. The landline is becoming obsolete now. The older cell phones, they have become obsolete. The things are changing so fast. Every day, is it not? एक साल हो गया तो क्या बोलते घर में? अरे पापा पुराना हो गया तुम हो गए. कितने साल हो गए बेटा? एक साल हो गया वो. You tell like that. So the things they go on absolute in electronics very fast. And the new things are coming up, the new generation is coming up. So I am not against that. What I am saying is that we have to think sometime, somewhere, that if somebody stops supplying us that IC, what will happen to us? Will you be able to use a mobile? No, not at all. And it's only thing in this universe you will find in electronics where as you advance, the cost reduces. Otherwise, everywhere else there is inflation and the cost increases. I will give you a simple example. You may find it as a joke today. 1885, I was being deputed, then it was BRC, now it has become VNIT, to IIT Mumbai for a course on microprocessor. 1885. The chip was invented then. Right? And believe me, how the chip was? The chip was kept somewhere else. How much it was costing, you know, in 1885 chip in those days? 1,000 rupees in 1985. The cost of 1885 chip in 1985 was rupees 1,000. Imagine 1,000 in 1985. So the chip was kept somewhere else. और हमें से देखते हैं हाथ नहीं लगा गया उसके कैपेसिटर साइड है चिप को कुछ हो गया तो 1,000 रुपये देना पड़ेगा 1,000 रुपये तनख्वाह नहीं देती दूर से देखो उसको so it should be something like oh don't touch it does so many things no CPU interrupts this and that it was something like revolutionary. And it was so dangerous to touch the chip that if something goes wrong, we'll have to pay 1,000. Today, you know what happens to your equity file? Is it not? The cost has reduced drastically. And even we won't use it now. What we need is the double layer, multi-layer, so on and so forth. Those things have become obsolete, the new things have come. Of course, the basic remains the same, as I said, and basic is there inside us. How we are acting. As I said, we are much more supercomputers or not? Just I give you the example. And probably you may not be knowing, when we say so, that anytime, anywhere, if you are traveling by a plane, you know all these companies, Indigo, Air India and whatnot, they don't want their plane at the airport. What they want? Always flying. Why? Because then they will get the reading. If it halts, they won't get it. Similarly, when we are using cloud, we want to use maximum utilization of it so that we will have the cost minimum and it is a more efficient system. And probably you might find that every day the cost is reducing. Earlier, when we were, I think 20 years back, there used to be some 3 hours or something, no? From 9 to 11 you had to call up to 6 and the calls used to get concessional rates. So now that system has gone. So the things are changing so fast. What I mean to say, what I expect from you, as I am saying as a technocrat, see how we can do, how we can improve this technology. It's not that somebody else, Japan is making and we are using. It's not that China is making and we are using. Someday, sometime you have to think that no, I will make it and then only I will use it. Till how much time we would like to be called as a developed country, a developing country, when we should call ourselves a developed country. The time has come now that we should be a developed country. And as I am saying that it is affecting your economics, it means that it also affects your development. And so you have to change so fast. Everybody has to wake up, see to it that you do something which will make a brighter India, a better India, a healthy India. And so I appeal to all the technocrats to come forward, to do something, to add something, whatever little bit. As I am saying, you take any example. You take the example of Google, you take the example of Facebook, any example. They are all being invited in the university at every tender age. Right? So you can do something. Don't think that we can't do. You have to always think positive that I can do it and then only you will do it. It's not at all a difficult task. Right? So with that, I again welcome all, I don't know how many participants are there, but the participants and my dear students to this conference. I wish it a great success. Something should come out, something you should know what the mobile and cloud computing means. Whatever little bit I was knowing, I told you, because it's not my field, I am basically electrical engineer, remember. Right? Though now the things have changed. Earlier, my department was electrical, electronics and computer science. Then it was diverted, it was electronics and computer. Now it was only computer and electronics were separated. Now electronics are also bifurcated, electronics and VLSI. So the things go on bifurcating over a period of time. Because as I am saying, it is the advanced time. But so there is nothing wrong. Simply what I expect from you, something positive, your attitude you should develop that you can do it. So with that, I wish a conference a great success. And as you know that everybody is happy because all of you are waiting for when the speech ends. Right? So with that, I close. Thank you very much.